when I started writing my paragraph about sodium, what I said was there was 11 protons on the inside of the nucleus because it's number 11. What I would do then, don't draw this until I'm done because then you'll see how much space that you need. What I would do is I would come in and using my blue pencil, I draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 protons on the inside. Don't do this until I'm done and you can see it. So 11 protons. We know there are other particles in there as well, the neutrons. We just haven't talked about the neutrons yet, so we're not going to worry about drawing them. So 11 protons on the inside part of the atom. There it is. That's the nucleus. So far, there should be some neutrons in there, but that's the nucleus with the number of protons in it, 11 protons. Now I need to take care of the outside part of the atom. The atom has two parts. It's got the inside, which is the nucleus, and it's got the electron cloud, which is the outside. The electron cloud is broken up into different areas of space. The nucleus is not. There's just the nucleus. It's on the inside. But when you deal with the electron cloud, the outside, there are different areas of space for the electron cloud. The way we find out how many areas of space there are is we have to look at the rows, which is going to tell us how many energy levels there are for that atom. So, when we look at sodium and we slide our finger sideways from sodium, we find a big number 3 on the side. So that means the outside part of the atom is broken up into 3 different energy levels. So what I'm going to do, and don't do this yet, wait till I'm all done, I'm going to draw energy level number 1, I'm going to draw energy level number 2, and then I'm going to draw energy level number 3. The outside part of the atom happens to be broken up into different areas of space, what we call energy levels. And we find the number of energy levels by what row that atom is in. And so because sodium is in energy level number 3, I draw 3 energy levels. This red part comprises the outside part of the atom. The blue part comprises the inside part of the atom. The inside part we call the nucleus. The outside part we call the electron cloud. Now, we already wrote a sentence or part of a sentence about what is in this outside part of the atom. The electrons. I just drew 11 protons on the inside, and so that means I need to draw 11 electrons on the outside. Now, what I want to show you is how we determine where those electrons go. Should I put all 11 in the first energy level, all 11 in the last? How do I determine where to put those electrons? Now, please take a look. We start with hydrogen, and all the way over on the right side of the periodic table is helium. Then we drop down to lithium, and then after lithium is beryllium, and then we slide over to boron, and then we go to carbon, and then to nitrogen, and then to neon. And then right underneath that is sodium. Okay? So, now, the 3 energy levels came from 1, 2, 3. Number 3, there he is. Number 3, so 3 energy levels. Now, well, the way we know what and how many electrons go into each energy level is this energy level right here, number 1, contains 2 elements, hydrogen as well as helium across that row. So that means energy level number 1 will contain 2 electrons. So in energy level number 1, I would draw 1 electron and 2 electrons. Somewhere floating around in energy level number 1, restricted to that area of space on the outside part of the atom. Then I go down to number 2, energy level 2, and I count across. 1, 2, 3, 4, 5, 6, 7, 8. In energy level number 2, I counted 8. Why do I count 8 across? Because I'm trying to work my way to sodium. So, in energy level number 2, I would put 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Then, we drop down to energy level number 3, but I'm only counting 1 space over because it's the first element listed in energy level, or row number 3. And so in that last energy level, I would put 1 electron on that outside in energy level number 3. Now, look at that first sentence. Sodium is number 11 because it's got 11 protons on the inside called the nucleus. And 11 electrons, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 electrons. They are not just sent to the outside part of the atom, all in the same space. Each atom is restricted to a certain area of space. These 2 electrons are restricted to energy level number 1. These 8 electrons are restricted to energy level number 2. And this last little electron is restricted to energy level number 3.
So don't stay there, it's not available for bonding.
Yes, it is the one available for bonding. So, the A column, if you slide your eyes up, above sodium is a nice big, now 1A. We said that 1A is supposed to be, the A column is the number of electrons available for bonding, available for sticking to or connecting with another atom. Why is that? Because when this atom is flying around, when it bumps into another part of the atom, it's not the inside of the atom that is going to collide, it's the outside. And not just any part of the outside, but the very outside. And that's why we stick it in column 1A, because on the very outside of the atom, even though it has 11 electrons, on the very outside, there is only 1 electron out there. So guess how many electrons lithium has on the outside? 1. And how about the guy below sodium, potassium? 1. Everybody in column 1A, the A column refers to the number of electrons on the very outside, which means on the number of electrons available for bonding or connecting with. Yes?
So if they have like more atoms on the outside?
Whoa, careful, not more atoms.
More electrons
on the outside.
Like make like a stronger bond or what?
Well, that's what we're going to be learning about. What is different about this guy versus everybody in column 2A? And what happens when you now have 2 electrons on the outside? Are you bigger? Are you smaller?
Yeah.
Do you react more? Do you react less? All those type of things based off the structure. That's why that paragraph says, chemistry, you'll have an opportunity to learn about matter, its properties, its structure, its composition, all based off of its atomic structure.
Alright.
Is that okay?
Yeah, I guess so. Okay.
Yes.
Is that why sodium bonds with chlorine?
Yes.
What about
Yes.
fluorine?
We'll learn all about that. All right. Now. Yes. Exactly. Now. Let's take a look, because I need to give you a rule about drawing it. Please take a second and go ahead and take care of the drawing for sodium. Don't do barium, because I'm going to give you a different rule for that. If you have 20 or less protons and electrons, I would expect, if I asked you to draw it, I would expect you to draw all the protons and all the electrons, if you have 20 or less. If you have 20 or more, I would not expect you to do that. So, for instance, barium. When we draw barium, this is how I'm going to draw barium. What I'm going to do is I'm going to start with barium at 56 protons. So I'm literally going to draw a 56 with a P and a plus. P with a plus is an abbreviation for protons, because protons are positively charged. That's why I use E with a negative. Electrons are negatively charged, so E with a negative and P with a plus. So this is the nucleus. Now, you have to be careful, because if you just use a regular pencil to draw this, you might think that that circle is an energy level and not the containment of the nucleus.
They use like different colors?
So that's why I was using different colors. So, I don't know, well, we can figure out something when we don't have it. So, immediately 56 protons on the inside called the nucleus. Yes, sir?
What if you box it?
It's not a box, though. It's like a spherical shape. Oh, there you go. So I should make these like cloudy. I don't want to, though. It's easy. That's a good idea. I'll think about that. All right. So now barium, we find barium in row number. Remember, the rows are going to tell us the energy level. The reason I wanted to write all those numbers in red, I wanted to write rows in red, I wanted to write energies in red, because I just happen to choose red to be for my energy level. So we find barium, we slide sideways, and we find that he's in energy level number 6. Would you expect barium to be a smaller or bigger atom than sodium? Bigger atom. It's got more energy level. So when we talk about the structure of these atoms, those are the things that we're going to be looking at. The number of energy levels, the number of electrons on the outside.